Good evening, everyone. I'm Bill Wetherholt. I'm an associate professor of geography. I'm also the department chair here, the Department of Geography at Frostburg State University. I teach varied courses that integrate geospatial things like cartography, intro to geospatial science and technology, maybe even GIS coming in the fall. I'm on the Teach OSM steering committee as well as the educational working group for Teach OSM. I am a chapter advisor for youth mappers here. We have a chapter here in Frostburg, and my OSM username is Mappalacha. So you're probably not overly familiar with Western Maryland. That little "you are here" dot is where the magic is happening right now in my building. But if you were watching the nightly news in the last week or so with the flash floods up in Western Maryland, that is right in my backyard, essentially. So that's just about 5 or 6 miles down the road from where we are tonight, or I guess where I am tonight. So I suppose to start, the best way to start is probably with geography's five themes. Um, so we should begin with the foundation. The five themes: location, place, region, movement, human environmental interaction. These were introduced in 1984 as a framework to organize geographic inquiry and education, built on further by David Hill here. It's a man I've cited. And originally, a lot of that comes from Patterson's 1964 work with the original sort of traditions of geography. But what happens when we try to use these themes as a lens or as a framework to kind of apply to OpenStreetMap? And I think if you don't already know, you will see that OSM is more than just a mapping tool. It's a dynamic platform that invites us to explore, contribute to, and critique our spatial world. So we'll start with location. And really what I did was almost like a mini literature review. I tried to find peer-reviewed work that sort of resonated with these different themes and scientists or researchers that were using OSM specifically. So if we start with location, location really answers the fundamental geographic questions: where is it? This includes both absolute location, so things like latitude and longitude, as well as relative location. So where is Frostburg in relation to where you are? Um, and so what I chose was this work by Sign On and Sign On from a couple of years ago. And if you look at this image, while we could probably pin it to specific geographic coordinates, it also functions in a web of relationships. So nearby shops, transportation access, tourist draw, things like that. And what these researchers did is they presented an interactive visualization system that tried to integrate user-generated online reviews with OpenStreetMap to explore spatial patterns in urban tourism. And the system extracts keywords from location-based reviews, renders them in a dynamic word cloud. You can see one of the figures here on the screen, and tries to tie them to geographic coordinates using OSM tiles. And users can interact with location markers on the map to see reviews relevant to specific tourist destinations, in this particular example, in and around Nanchang, China. In terms of like key OSM interactions, or how these sort of where OSM and location intersect, with absolute location, relative reviews are anchored to real-world coordinates using latitude and longitude and enable precise geo-visualization of this tourism data. With respect to maybe relative location, users can explore spatial context, say the proximity between different attractions that have been reviewed within that mapping interface. In terms of educational or practical applications, I am on the steering committee of Teach OSM. The work highlights the power of OpenStreetMap as a platform for spatial data storytelling and interactive decision making. And for educators and contributors, it shows how geographic data can be merged with user experiences to contextualize place-based digital information. Okay? With respect to place, right? I just mentioned place. Um, Place involves both physical and human aspects. Really, you can see on my bullet points there, like all places have both human and physical criteria that distinguish them from other places. That sort of fuels geographic inquiry. Tobler's first rule of or I guess fourth rule, first rule. Don't quote me on that. I'm in the weeds. Let me keep moving. But so what I used for place, take this image for example. Here you see a typical urban street with trees, maybe some associated natural capital, people at ease, kind of in the background, strolling. But how green it feels might vary from person to person. Levels of greenness are arguably subjective based upon who you're talking to. Right? And so what these authors did, you can see the title is How Well Do NDVI and OSM Data Capture People's Visual Perceptions of Urban Green Space? And I think I should just start with a little shot of NDVI. If you're not familiar with the Normalized Difference Vegetation Index, this is a shot from last month at my boys' elementary school for career day. They loved the drone. But what you see is a real, like a RGB, red, green, blue image on the left, and sort of a real-time NDVI on the right. Higher values, hotter colors, lower values, cooler colors. So this NDVI is commonly used remote, it's a commonly used remote sensing metric that quantifies vegetative health and density by looking at how surfaces reflect light in red and near infrared portions of the spectrum, right? And so it gives you a really quick or a good, it gives you a good indication of vegetative health, levels of greenness. Precision agriculture utilizes NDVI pretty regularly. So if vegetation is healthy, it's a stronger value. If it's stressed or unhealthy or not vegetation at all, it's a lower value or maybe a negative value. And so this paper examined the relationship between two spatial data sets, NDVI from satellite imagery and OpenStreetMap, and then people's subjective visual perceptions of urban green space, right? Like the original like opening shot is a shot of that the survey that was deployed, and you can sort of see a shot in the bottom of that figure on your right. So those subjective visual perceptions of levels of urban green space. And researchers crowdsourced ratings from participants using that Google Street View imagery for three European cities, Barcelona, Rotterdam, and Gothenburg, and compared the data to levels of greenness that were reported from NDVI. In terms of how it really embodies themes of place, um, I mean, there's crowdsourced perceptions of greenness in specific places. It incorporates not only vegetation, but even like sort of subjective feelings of safety and attractiveness and quietness, sort of contextual understanding of urban space. Physical characteristics like vegetation, the built environment encroaching upon vegetation, spatial heterogeneity, things like that. Um, it found that OpenStreetMap was best matched, finding like perceptions of greenness at short distances within about 15 meters, making it more aligned with how people perceive their local surroundings. Tag spaces like parks, play areas, pocket parks, they were perceived in varied levels of greenness. There's a couple of examples that are here. So like on example A, it was perceived, that particular point was perceived as very green by all the participants who viewed it, but it had a pretty low NDVI rating. Whereas on the right in B, it was perceived as not being, I mean, it was sort of all over the place as to levels of greenness and how people perceive that particular image. But the NDVI scores from satellite imagery reported as being a very green area, right? So sort of toggling between how people perceive levels of greenness between the way it's tagged in OSM, the way it's viewed in this survey, and what the satellite data says. And so they kind of show these different examples. Participants often describe places as green for an urban environment, sort of emphasizing contextual perceptions. And places with similar NDVI or OSM tags were sometimes perceived differently based upon local spatial character, kind of reinforcing the idea that place is more than data. It's a subjective sort of lived experience. See on the left in C, perceived green by 6 out of 7 people who viewed it, but it wasn't tagged as green space in OSM. It was tagged as play space. And then on the right in D, sort of the mostly concrete looking area, it was not perceived green by any of the survey respondents, but in OSM it was tagged as a park. So it was showed up as green, as well as an open public space and a play space. So all of those sort of open green space activities, not perceived as green, although maybe the way it looks on OpenStreetMap would suggest as such. So just interacting with place through OSM. Um, and then places that are nearby are similar to one another. That's sort of the idea of regions, whether they are formal regions like city boundaries or functional regions, say like, I don't know, a TV market area or vernacular regions, like what is the South or the Pacific Northwest? So these unifying characteristics, be they infrastructural, economic, linguistic, etc. So regions are a fundamental theme in geography, and trying to use that theoretical lens or that foundational lens to look at OSM, I pulled up this particular author. They were looking at OpenStreetMap data to measure and compare pedestrian street lengths in almost 1,000 cities around the world. And what they did is they analyzed pedestrian street networks using OSM data and R programming. They focused exclusively on streets that were tagged as like the highway equals pedestrian tag. And it allowed them to sort of quantify and compare car-free infrastructure across standardized urban regions. And I mean, even the summary itself in terms of what they came up with is summarized in a regional context. So really, this study really does embody the theme of region through OSM. The authors apply a common spatial definition to cities. They looked at systems of pedestrian mobility. There were even sort of perceptual regions, sort of these implicit cultural values about car-free planning, say like comparing and contrasting different regions and maybe how they view the personal automobile. With the key findings, Europe dominated in terms of the geography of the world with the amount of walkable pedestrian street lengths. Particularly in Spain and the Netherlands, you can see Paris is number 1, but Barcelona, Madrid, Rotterdam, Amsterdam, etc. North American cities, oceanic cities, they lag fairly significantly. Attributed mostly to sprawl, car-centric planning, things like that. Even regional inequalities were elicited in this work. 101 cities, mostly in Africa and Asia, reported 0 pedestrian street data, which reflects more gaps in OSM coverage than it does gaps in walkable infrastructure in that particular region. In terms of maybe practical implications or educational applications, again, Paris and Barcelona led all of those almost 1,000 cities with more than 200 kilometers of pedestrian streets in each, defining them as walkability exemplars or pillars in the global landscape. But it really emphasized how OSM can support these regional analyses or these comparative analyses. It's a valuable teaching tool for showing students how regions can be analyzed quantitatively using open data and reproducible methods with things like R. I think they used Overpass in there as well. And it sparks discussions about data completeness in developing regions. and how OSM can both reveal and help address these gaps in data. How am I doing on time? I think I'm doing okay. Taking a look up at my clock. Um, with respect to things moving through space, right? Movement. Those are the connections beyond our immediate proximity, right? The diffusion, the flow of ideas and communication and transportation and just all of the flow of ideas and infrastructure and us, the interconnectivity of us. The study that I utilized, this 2020 study, it was developed within the Via Libera project in Milan, and it compared various field and digital methods for collecting and mapping pedestrian accessibility into the OSM ecosystem. The goal was essentially to identify optimal workflows for mapping architectural barriers, sidewalk quality, slope, street crossings, things like that, the things that affect mobility, the things that physically affect movement across space. Um, so it really highlighted how physical infrastructure, so say things like sidewalk width, curbs, slope, barriers, influences the flow and freedom of movement in the city space. It directly supported accessible route planning and sort of showed how VGI, volunteer geographic information, or citizen-generated geographic data, how it expands our understanding of who can move through urban space and who can't. It compared, I guess I'm getting ahead of myself, but it compared different field mapping tools, things like field papers, different mobile apps, street level imagery to work on things like accessible mapping. It was really a helpful paper for people on like how to think about mapping walkways in particular. If you look at the example on the left, all of that red line of that walkway is tagged as a footway, and it's a sidewalk. The surface has been articulated, so what you're walking on or navigating across, the smoothness of it, the width of it. And the article also talked about trying to integrate barriers and obstacles, and you can see that like they tagged instead of tagging the street sign or the traffic sign directly on the route or on the walkway, they marked it as a point feature right next to that line feature. And then you can see sort of between segments A and B, the width of that sidewalk is truncated slightly to account for that possible accessibility issue. And same thing in the example on the right, sort of giving a guideline for good tagging in terms of the white outline being for the entire amenity of parking, but not all of the parking is accessibility parking. Capacity is 3, 2 of which are accessibility parking, and then you can see the orange and the yellow tagged individually as accessibility spaces for the disabled. Right, so they looked at these different field papers to try to increase like those being ways to increase not the validity, but the accuracy of the environment around them. In terms of educational practical implications, I'll get back to that in just a second. It demonstrated how mapping movement isn't just about roads or transportation networks, but also about the inclusive design of everyday spaces, like on our sidewalks. And a pretty strong example for students of how OpenStreetMap is being used for equity-oriented mobility planning. This is a soft pitch for those of you that don't know the current grant program that is in effect. So the camera grant program, which is directly linked to things like Mapillary, you see on the right-hand side there, that's a Mapillary image of Frostburg, just on I guess, the east side of campus. You're not really oriented north-south in these crazy mountains. But if you have students that are interested, or a Youth Mappers chapter, if you're interested in gathering some street level data, there is a grant that is ongoing right now. I would encourage you to apply. If any of my students are in on this, I encourage you to apply. Let's talk. Okay. And then human environmental interaction. So, I mean, it was Patterson's man-land tradition, renamed the human environmental interaction. And really, any location has advantages and disadvantages for our habitation within it. And we alter our environment and adapt to it in ways that says something about who we are. Different cultures sort of manifest themselves on the physical landscape in different ways. So this human environmental interface or nexus is a principal theme in my discipline of geography. And I would argue that Yang Fu Smith and Yang et al. In 2017, had a pretty solid paper that sort of articulates or resonates or overlaps between the five themes in the OSM ecosystem. The study in particular developed a scalable method to try to map land use patterns across the southeastern United States. Notice the little yellow footprint of the study area. You can't see the legend, but that's what that yellow footprint is there. So kind of straddling the Georgia-Florida border. And so what they did is they tried to develop a scalable method to map land use patterns across the southeastern US by fusing together OpenStreetMap with remotely sensed imagery via the Google Earth engine. The authors distinguished land use from land cover using OSM data, especially land use, nature tags, places tags. You can see all the different land use labels in the OSM ecosystem in the study area there in the figure that I incorporated. And what happened, the result is a very high accuracy land map that shows how human activity transforms and manages natural environments at a regional scale. The example on the right is sort of an amalgam of all the different sort of training sites that they put together to try to get this all to work. Um, uh, the OSM, OpenStreetMap features provided localized, volunteer contributed training data for land use classification, and it offered a ground level layer of human activity that is not captured by remote sensing techniques alone. The study relied on the positional accuracy and attribute richness of OSM features to improve classification of complex human influence landscapes. And the authors emphasized OSM's temporal sensitivity, like the time frame, temporal. The temporal sensitivity, really highlighting how its constant updates in the OSM ecosystem support real-time monitoring of land use change. In terms of practicality and educational connections or implications, it was a clear illustration of how OpenStreetMap can be integrated with environmental monitoring tools to detect, visualize, and understand the footprint of human activity. And it highlights the importance of volunteer geographic information, that local knowledge that OSM thrives on in supplementing satellite-based observation, which is really ideal for discussing participatory science and community mapping. So, to bring it all home and to try to not co-op, not use more time that I should be allotted. Um, Geography's five themes, they offer a powerful lens for understanding and applying OpenStreetMap. It's a fairly efficient sort of theoretical lens to investigate this web mapping software that we're here to talk about. But it's more than just a web mapping software. OSM's not just a mapping platform. It is a tool for spatial inquiry, for community engagement, and for critical geographic thinking. The five peer-reviewed articles that I pulled into this nonsense sort of demonstrate how OSM data can inform and be informed by geographic concepts at scales from the local to the global, and from visual perception to pedestrian mobility, to land use change. All OSM supports that, whether we're talking about quantitative inquiries or qualitative inquiries. It really can facilitate both. So the intersection of OpenStreetMap and geography's five themes, I would argue, opens doors for education, research, and ultimately civic participation through the map.
So yeah, hi, I'm Jake. I am a OpenStreetMap enthusiast and software developer, and I work for OpenStreetMap US, maintaining various software tools that we provide a home for at the organization. And one of those tools, which is what I'm here to talk to you about a little bit tonight, is called OSMCha. So you may have heard of OSMCha. It's a change set viewer and validation tool for OpenStreetMap. And if that's not familiar to you, I'll walk through what that means really quickly. So if you've edited OpenStreetMap, you probably know that when you are finished with your edits, you usually click a button that says save or upload, and you type a comment that says to other mappers what you did. And that does two things. It edits OpenStreetMap. It publishes your changes for the rest of the world, but it also creates a record of what you did that other mappers can go back and view later. And OSMCha is a tool for viewing those records of what changed at different points in the past in OpenStreetMap. And this is a really useful having that historical data of what changed over time is useful as a quality assurance facility for OpenStreetMap. It means that you can go back and look at, if you see something on the map that might be wrong, you can go back and look at the history of that thing and try and understand, was it always this way? Did it change to be like this recently? Who changed it? Who might know more about whether or not this data is accurate? So the interface that you see that I'm screen sharing is OSMCha. This is what you would see when you go to the website. It's osmcha.org. When you first visit, you'll need to log in with your OpenStreetMap account by clicking a button up here in the upper left. And then once you're logged in, this is what you'll see. And this is a list of recent changes that everyone everywhere in the world has made to OpenStreetMap. And if I just click on one of these changes, it loads a map that shows you a visualization of what this particular edit did to OpenStreetMap. Um, and I'll just click through a few of these so that you can get a sense of what you might see if you load OSMCha. So what you're seeing is it's OpenStreetMap data overlaid on top of a satellite image base map. That's just for context so that you know where you are. And you're seeing OpenStreetMap data that was changed in this user's change set. And it's color coded. So green are things that someone added in this change set. Yellow are things that someone modified, and red are things that someone deleted. And gray is modified as well, but it just means they only changed the shape of like a building or a road. They didn't change its tags. Um, so, here you can see something that was deleted. And if you click on these individual features, you can see a pop-up opens that tells you more about what was changed. So you can see what was this thing that was deleted? What did it used to be tagged as? And here it says it was land use equals grass. So that means that this was a grassy area that someone noticed was not there anymore, and they removed it from the map. Um, so when would you use OSMCha? What would bring you to OSMCha? There's a couple of different ways that you might interact with it. The first one, which I do a lot, is if you're looking at OpenStreetMap and you're curious about something that you see on the map. You can click this button here that says Query Features, and you can click somewhere on the map, and it will bring up this list of features that are near where you clicked, and you can tap on one of them. And one of the things that you see is a record of who the last person who touched this was, and when it was, and what change set they were working in. So this actually happens to have last been touched by me. And if I click this link, it shows the change set that I made about a year ago that last modified this waterfall feature. So one way that you might go to OSMCha is if you wanted to learn more about this change set, you can take this number, the change set ID, and you can go back to OSMCha, and up here in the URL, you can type it where it says change sets slash, you can paste in that change set number, and that will load this change set. And you can see exactly what I changed a year ago. I don't remember what I changed a year ago, but using this tool, you can kind of tell. You can see that there are some new features that were created, these green lines. There's a red line that was deleted. This yellow dot, I think that's the waterfall that I clicked on. So that was modified. And you can click on individual things to start to get a better sense of what's going on. So it looks like I added these two different streams, and I deleted this stream, and I changed the alignments of some of these other ways, like the trail. Um, So that's one way that you might arrive at OSMCha is if you're looking at OSM and you want to get more details about a specific change set. Another way that you might use OSMCha is you can use OSMCha to monitor changes as they happen, and create a queue of things that you can go review. So you can click this filters button, and this will let you apply lots of filters to all new change sets that are happening to OpenStreetMap. And that way you can monitor those types of changes. So I live in Washington. So I'll type in Washington here so that I can monitor my local area. And I like to map trails. So maybe I will set up a filter for every time someone makes a change set in Washington that where they say something in their change set comment about trails. And when I click apply, what's now in this sidebar are just edits that fit those criteria. Here's one from about an hour ago. And so if I was interested in making sure that changes that were happening in my area to this type of data were correct and accurate, I could treat this like a review queue, and I could go through it. This is like an inbox that you can come back to, and click through stuff that, edits that have been made recently in your area. And you can look at the description. There's lots of information available in this bar here about what changed. Um, you can click on the individual features on the map and see data about what changed. So this is a really powerful tool for reviewing edits. And there are a lot of people who volunteer, to contribute to OpenStreetMap, where this is one of their primary ways of contributing. Is like, I mean, often they're also mappers, but there are a lot of people who are reviewing change sets, helping point out other people's errors or spot vandalism or just mistakes that happen when people are editing, and then notify those people or correct those issues. So that's another way that you can use OSMCha. And then I'll just finish with some thoughts about how, since we're kind of on the topic of education tonight, a couple of ways that OSMCha could be useful in the classroom. So I think the first way that comes to mind is if you're an educator and you're teaching students about geography through OSM and you're having them edit OpenStreetMap, OSMCha can be a really useful tool for you to review the work that your students are doing, and notice any problems that they might be making, problems that they might be having, or misunderstandings that they have as they're editing OpenStreetMap. And you can point that out to them, either through OSMCha lets you directly message the author of a change set, so you can get into contact with the user who made this change through OSMCha. But it's also, you can also contact them through other means, obviously. So that's one way that you can use OSMCha, is to follow, like, what that might look like is if you come back to filters here, you can enter the usernames of some other OSM users, and then you can get a queue of those users' edits. So if if you have students who are working on an assignment, or if you're part of a mapping club and you all want to follow each other's edits, then that's a way that you can use OSMCha. But the other way that I think you can use OSMCha in the classroom is just to look at your own edits. I think that everyone can benefit from this. I do this all the time, even though I've been mapping for years. If you go up here to the corner on this drop-down menu, one of the options is My Change Sets. And you can that shows you the change sets that you've made. These are all the recent change sets I've made. And I think it's really educational to look at your own change sets and kind of review the data that you generated and make sure that you understand why it looks the way it did. Because sometimes you'll spot things that it's like, oops, I didn't mean to edit that, but I did. Or maybe like, oh, I edited this, but now that I'm looking at the change set, it's like how everyone benefits from a proofreader. And sometimes it's even good to proofread your own work. You'll catch things that you didn't notice the first time through, and you'll learn more about the process of writing, or in this case, mapping. So those are a few different ways that you can use OSMCha, and a couple of ways you can use OSMCha in the classroom. I think I'll stop there, and if anyone has any questions about OSMCha, I'm totally happy to answer them. And thanks for your time.